Okay, let's look at an example on page number 34. In this example, we have to compute the determinant of this matrix using the row operations. Here is the solution. So the given matrix is this one. So first of all, our aim is to make this entry 0. How can I make this entry 0? If I write 3 minus something times using this pivot entry is 2. So do you know what should I write here to make this thing 0? Okay, if you don't know, this is the trick that just put here, this is 2, just put here 3 by 2. This entry up and this entry down. If you put this way, then you can check that this entry will cut by this entry. You will get 3 minus 3, which is 0. So in this way, you can write that this is R2. So I will write R2 minus 3 by 2 because this is 3 and this is 2, which I have written, times R1 because this was the pivot entry. And similarly, you have to make this entry 0 too. How to make this entry 0? If you write this entry 5, then minus something times the pivot entry 2. So what should you write here? Again, I told you, write this entry on the top and this entry below. If you write in this way, then this entry will cut by this entry and then 5 minus 5 will be 0. So that means you have this minus 5 by 2 times this. What does that mean? R3 minus 5 by 2 times R1. So these two operations I will perform in this matrix. Okay, let's write the first row as it is because we have to perform these two operations on the second row and on the third row. So the first row will be as it is. So firstly, I have to perform this operation in the second row. So first of all, I will write R2 as it is. R2 is 3 minus 2, 0. You can check 3, 2 minus 2, 0. Then I have to write minus 3 by 2. So let's write minus 3 by 2 everywhere. You can check. I have written 3 by 2 everywhere. Then I have to write R1. What is R1? 2, 1, minus 1. So I have to put 2, 1, minus 1. You can check here, everywhere. And in the last row, I have to write R3 first. So I have written R3 first, 5, 1, 6. You can check 5, 1, 6. And then I have to write negative 5 by 2 everywhere. You can check I have written negative 5 by 2 everywhere. Then I have to write R1. Since R1 is 2, 1, minus 1, so I have written 2, 1, minus 1 in the slots. So if I do the calculations, so this is the process how we will make here 0 and here 0. If we make these calculations, I will end up with this matrix. Now, if I expand this determinant along this column, if I expand this determinant along this column, I will first write this entry plus this entry plus this entry times the determinant of submatrices. But I will only write this entry because these two entries are 0. So I will write only the first entry. So when I will write the first entry, Then I will skip this, I will skip this, I will write the determinant of this submatrix. So I have written the same thing. Now if I write this 2 and write the determinant of this, I will get this, and then after little simplification, my answer is negative 55. Now let's solve another example. So in this example, we are given that the determinant of this matrix is equal to 4. The determinant of this matrix is equal to 4. This is given. And we have to compute the determinant of another matrix. So that matrix is this one. Okay. So let's look what is the difference between these two matrices. So if you look that if I swap these two rows, I will end up with this matrix. Can you see? Because you can check that this last row and this first row are the same. Similarly, this last row and this first row are the same. And the middle row has no difference. So that means in the given matrix, if I swap R1 by R3, then I will get this matrix. So let's start from the given. I have written the given matrix. Then I will swap the rows. You know, when I will swap the rows, the rule says whenever you swap the rows, the determinant becomes negative. So I will write this negative sign times the determinant, the swap, right? So the matrix which is to be the determinant which is to be found is this one. But another matrix which we have taken from the start, it is given that the determinant of this matrix is 4. Okay, if we compare these two, we will end up with this equation. So if I put the value which is given in this equation, the value of the given matrix is the determinant is 4. So I will write 4 here. So you can check that the determinant of this matrix, negative the determinant of this matrix is equal to 4. In other words, the determinant of this matrix is equal to negative 4.